In this video, we're going to review how to analyze the EtherCAT telegram being exchanged between an Omron PLC and a Festo servo drive. Now, this can be any other EtherCAT master. In for this particular case that I've been working on, it's an Omron PLC, but it could also be a Festo PLC, a backoff PLC, whatever EtherCAT master you can get your hands on. So right in front of you on the screen, I have the topology that I have laid out in my desk right now, which is basically this laptop that I have right now where I'm recording. This is connected via TCP/IP directly to this device. This device, it's called Tap Curious. It's created or it's marketed by a company that's called Kunbus. So that's Kunbus. I believe it's phased out, but maybe they have a newer version or something, or I don't know. Maybe you can get another type of device that does the same thing. Basically, what this device does is that it intercepts the communication that happens between two devices. So you see this connection right here. This connection right here. It's almost there's almost no latency. I believe on the website from Kunbus they say that there's zero latency, so there's no delay. But basically, it just intercepts the data that's coming over some sort of Ethernet communication from this port to this other port. So in the actual application, this PLC here on the left, the Sunrun PLC, is connected directly to the Festo servo drive. What we're doing for the purpose of this analysis is we're intercepting the telegram or the communication and analyzing it here. So let's have a look at how this is going to work. And basically, I'm going to use two pieces of software mainly, which is going to be, one of them is going to be Wireshark, and the other one, it's going to be the Sysmex Studio from Omron. At one point, I'm also going to utilize the command prompt. So I'm going to show you how to do this directly using Tshark from Wireshark, but we'll get to that later. So first things first, I'm going to start a new capture and actually do it here. Close. So when you open Wireshark, it basically looks like this, where it's going to show all of your network interfaces. In my case, this laptop, I'm just connected directly with an Ethernet cable to the Ethernet port, and then I'm going directly into that Tap Curious device, right, via TCP/IP, as I showed on the previous image. So now you have to select your network interface. In this case, mine is this one, Ethernet. So I double click on it, and then it's going to start capturing data right away. Now there's going to be a lot of packets, as you can see here. There's many packets. Within 5 seconds, there's already like 10,000 packets. So I'm going to stop it right now, and then you're going to see. I already have it marked here for you for making this video simpler, but here you're going to see that there's between all of these packets, oops, if we look at the last two packets, is number 10,372 and 10,373. So let me start with the very last one, 10,373. If you go down under the EtherCAT telegram for this particular packet, and you go all the way down to this LRW section, here is where you're going to find the process data for within EtherCAT, which is a PDO, right? This is the data that we're transmitting to the drive, so that the Omron PLC is transmitting to the Festo servo drive. And on the other packet, on this one, 10,372, this is the data under the same thing, LRW. This is the data being transferred from the servo drive, Festo servo drive, to the Omron PLC, or from the Festo servo drive, which is the EtherCAT slave, to the Omron PLC, which is the EtherCAT master. Okay, so how do we figure out what these numbers mean? Well, in the user manual, I'm going to show that here. If you download this user manual, this is a user manual for the CMMTAS servo drive, software user manual. Here you can find, which page was it? Search for PDO. Here you can find the structure for the PDOs, here, PDO mapping. And then if you scroll down here, you're going to see the control word, so the receive mapping or receive PDO, and then the transmit PDO or TX, right? Status word and then control word. So this, the receive this is received by the CMMT, right? And the transmit, this is sent by the CMMT servo drive. And how do we know this? Because, for example, here it's transmitting the actual position actual value. On the receive, because remember this is being received by the Omron PLC, this is sending, or this is sending the target position. Okay? Or this is being received by the CMMT, that's why it's received. So target position. Okay. So now what I did here, for the simplicity of not having to navigate between the PDF and so on, I just added this as an overlay so I could show you. So I'm gonna be, switching between those two. So let's have a look. Right now, this what I'm going to do is, it's a little difficult to be running, or I didn't find a way to be running the with a certain frequency, running Wireshark. The only way that I found is by utilizing this Tshark from Wireshark on the command prompt. And basically, if we utilize this command here, which is basically Tshark, this is the application, minus or dash I6, this is the network interface number 6. Dash C2, this is how many packets do I want to acquire. So this is count, I believe, 2. And then T dash T fields. So I believe this is, I will have to read it again, but what I found is that this is specifying that I want to receive or print the fields on the command prompt. And then here with the dash E, I'm specifying which fields are the ones that I want to acquire. How did I find out, for example, this field? You can go back to Wireshark, and then since we know that it's under the LRW and it's this data, you can right click on it and then copy field name, and then you just paste it somewhere else in a notepad or something. And that, so if I do that and I open notepad and paste that, so there you go. That's how I figured that out. And so if we run that, it's basically going to acquire those two packets, or the last two packets, right? Which are the transmit and receive. So it's coming along now. So now you can see it here. So these are the ones that we're interested in. So here's the data being sent by the Omron PLC, and here's the data being sent by the Festo server drive. So how do we know what each of these mean? Well, remember that we have these, what you can see on your screen right now, this is the overlay. So let's start with this. And I'm just going to show you a couple. So this portion over here, 0D00. These are actually flipped, okay? So it's actually 000D. So if I open a calculator and then enter the programming mode, here, I put it somewhere we can see it here. I'm going to type in 000D, which is basically just the D. In decimal, that's a value of 13, right? Okay, where is this value being sent from? So at this time, we go to let me just close all of these other calculators. And okay, so at this point, we go into Sysmex Studio, and here, my drive, my function block on Sysmex Studio, is sending a 13. Okay, so this is where this value is coming from. Now, if I enable the drive, you can see now, instead of a 13, now it's a 15, right? So let's run this again, and let's take a look at that same value. Okay, it's capturing. There it is. So now that value says, remember, it's these two sections, right? So 0f and 0, 0, they are inverted, so it's 0, 0, 0f. So if we take a look at what 0, 0, 0f means, that's basically an f, that means decimal 15. Okay, so that's how we capture the control word. At the very least, we're getting the control word. Now, let's take a look at the data being sent by the CMMT. So if we take a look on your screen, the status word. So the status word right here on the function block, it's saying that the current status word is 1591, 1591. So is that the case? Let's see here. So if we type in a 1591 in hex is 637. Where is this 637? If we take a look at the little table that you have in front of you, it says that the status word is the very first portion of that telegram or that data, right? So it's right here, right? And remember that it's inverted. So 637, 0637. 0637, it's basically telling me that the current status word is what? 1591. You can see it on the status word. Oh, and I'm sorry you couldn't see it before. Let me move this a little. This. Now you can see it there. 1591. I'm actually going to move this. Move this a little bit out of the way. Maybe put him here next to me. So, okay. So 1591, all right? Now, another interesting piece of information or data that we could see here is the position actual value, which you can see on the third position on the right hand side on the table on the right. It's status word, then modes of operation display, and then position actual value. What is my current position? It is 2605. Okay, so if I look, type that in, 2605 in hex is A to D. So what we have to do here now, let me probably leave this open. So we look at the table, it says it skips one cent, which is 1 byte. So it skips this, these two zeros here. And then the next 4 characters, or the next 2 bytes, should be the actual value position. So here we can see 0A to C with this change. The 2605, 0A to C. Why? Maybe I'm missing a value. Let's see, in hex A to C, it's 2604. Maybe it's oscillating a little bit. So if I'm moving the shaft, oh, you know what? Maybe it did change. So before it was 2604 at one point, but this is not updating continuously, right? So let's update it and see if that value actually changed. Updating now. Okay, so it did change. Maybe when I last time that I run this little script, the position changed just by 1 unit. So now we can see here 2605, 2605. It's A to D, which is here, 0A to D, right? Perfect. So what else can I show you here? I think that's basically it. This is a way for you to decipher this data. And again, I did this just because it's easier for me to just run this command here that I showed you on the command prompt, and run it every time that I make a change in the function block. But you could also run it directly here in Wireshark, right? You could run it continuously here in Wireshark, and then just I didn't find a way of always showing the last. I'm constantly hitting the end key on my keyboard, but otherwise, it keeps updating here the last packet, but this below doesn't update. But here you can also find the data, right? The data is right here. If we stop this again and we look at the very last telegram, remember this one, this telegram has a 0f, which is basically saying that it's sending a control word of 15. And the last telegram, or the one before it, is the one from the CMMT drive to the Amram PLC. So this is basically sending the status word, the modes of operation display, and the position actual value. And here you can see the same thing, 0A to C, which is 2604. So that is a way of utilizing this device, this tab curious device, and deciphering the EtherCAT telegram.